All right, here's your free response question for today. So you're given a equation, and you have to take the derivative of that equation. And you can see x and y are mumbled together, and you have to show that the derivative equals this. Can you have the skill to derive implicitly? I know you can. So the derivative of 2x squared is 4x. The derivative of 6, or 2y, 3y squared is 6y, but then it needs a y prime. This is the tricky part, which isn't tricky for you. 4xy is the product rule, and you've seen it so many times. That's the first times the derivative of the second plus the second. We're going to call the second negative 4x, or the second is y, I mean. Do that. So times the second times the derivative of the first, which is negative 4. There's the negative. And then the derivative of 36 is 0. You can do that. Then if it has a y prime, it's going to stay. And if it doesn't have a y prime, it's going to go. So 6y and y prime, that's staying. 4x and y prime, that's staying. And then we're going to subtract 4x. This is negative 4i, so we're going to add 4y to the other side. Then we're going to factor. And then the last step is we're going to divide. Now, we'll write it the way they want us to. So we know that y prime is dy by dx. And then, if we reduce this down and write it in different, negative 4x and 4y, 6y and 4, we can divide top and bottom by 2. We don't have to show that we're doing it, just simple simplifying. That's 2y minus 2x. This is divide by 2, 3y minus 2x. Boom. You just showed that that derivative equals that. Good job. Part B. Find the slope of the line tangent to the curve at each point where x equals 6. So in order to find the slope, that's our goal, that's the derivative. So the derivative is 2y minus 2x and 3y minus 2x. Now we know that x equals 6, but what we don't know is what y equals. So we need to go back to the equation at the beginning, and where there's an x, we're going to plug in 6, and we're going to solve for y so we can find that slope. So I'm just plugging in, where there's an x, I'm plugging in 6 at the beginning of this question up here. So taking the original equation, taking out 6, taking out x, putting in 6, and solving. So 6 squared times 2 is 72. Plus 3y squared, that's minus 24y equals 36. Now this is a quadratic equation, so I'm going to make it equal to 0 and put it in the right order. So we have 3y squared minus 24y, and then I'm going to subtract 36. So when I subtract 36, it's now plus 36. So the reason it's positive is because of the positive 72. Take away 36, and then divide everything by 3 so that everything's easy peasy. So we get y, two solutions, to 12. So that's negative 6 and negative 2. So y is 6 or 2. Now, do we have anything in there that would tell us which one it would be, 6 or 2? So let's try one and then the other. So there's actually two answers here. So one for 6 and one for 2. So if we try 6 first, then at 6, 6, that point, what is the slope equal? We don't need to reduce down. Plug in 6, and you have your answer. Then the other one is at 2. So the other one is at 6 and 2. And again, I don't need to simplify that. So again, just plug in 2 for 6 for x again and 2 for y. 6, 2 for y and 6 for x. Come on, I can do that. And there he is. So you found the slope, and in this case there are 2 possibilities. So you're looking for 2 answers. And you could simplify this down. That's 12 take away 12, that equals 0. If you wanted to simplify this down, was that negative 8 and negative 6? So negative 8 over negative 6, the same as 4/3. All right? Yeah. But not necessary. All right, let's keep going. Part B. See now. Find the positive value of x at which the curve has a vertical tangent line, and then show the work that leads to your answer. So what does that mean? That means it's when the slope is undefined. That's what it means. So we have the slope, and the slope again was 2y minus 2x and 3y minus 2x. And where is that? It's taking the denominator and making it equal to 0. So if we take the denominator and make it equal to 0, then if you get y by itself, we're going to add 2x and then divide. So you get 2/3 x. Then we need to substitute back into the equation. So it says find the positive value of x that has a vertical tangent line. So we did this work, and now we know what y equals. So think of it like a system. Go back to the beginning, which you have 2x squared plus y squared minus 4xy equals 36. Now, wherever there's a y, put in 2/3 x. And now you're solving for x. So we have 2x squared. We have the 3's divide out. No, we're squaring, right? So that's 4 over 9x squared. Here, if we multiply it out, negative 4 times 2, that's 8 over 3, and it's negative x squared, and that's equal to 36. So you can see all of these x squares that we can factor out. So if we factor out the first one, you get 2. If I factor out the next one, 3 goes into 9 3 times, so I have 4/3 minus 8/3. And that's all equal to 36. I'm going to simplify this by getting common denominators. So to simplify this to get common denominators, I just need to multiply it by 3, this one. So I have 6 plus 4, 10, take away 8, so that's 2/3. And then the last step to get x by itself, or the second last step, is to multiply times the reciprocal. So if I multiply times the reciprocal, 2 goes into 36, 18, and 18 times 3 is 54. And we don't have to simplify this down, but know if the answer could be positive or negative, the square root of 54, and that's a great answer. Oh, because x is positive. Does it say x is positive? Find the positive x value. Be a good reader. So the only answer is positive root 54, because this says find the positive one. You do not need to write that in simplest form. Root 54 is equivalent to if you wanted to simplify it as, whatever, would it be 9 times 6, 3 root 6? That's no better. It's just perfect the way it is. All right, part D. Let x and y be functions of time that are related to that equation at time equals 1. The value of x is 2, the value of y is negative 4, and dy by dt is 4. Find the value of dx by dt at time t equals 1. So this is like a related rate. So can you take the derivative with respect to time? So we're going to take the derivative of each one, but not respect to x, but to t. So what's 2x squared? That again is 4x, but it needs a dx by dt, because it's with respect to t. 3y squared is going to be 6y, but again it needs a dy by dt. This needs again to be the product rule. So that's the first times the derivative of the second. Now the derivative of y is just 1, but it needs a dy by dt, plus the second, which is y, times the derivative there, which is negative 4, but needs a dx by dt, and then the derivative of 36 is 0. Now I need to start substituting in what they've given us. So it tells me that at time t equals 1, the value of x is 2. So wherever there's an x, I need to plug in 2. It says that dx by dt says find that value, so I don't know what that is. Y, they said, is negative 2. dy by dt is 4. I'm just going to keep plugging in values here. And then you have to solve for dx by dt. So we have 8. I have, what is this, 24 and double it. That's what, negative 48. I got 16 and double it. That's what, 32. And I got plus 8. Dx by dt equals 0. So 8 and 8 would give me 16 dx by dt. And then this is negative, what is that, 70, 80. Add it to the other side, so it's positive 80. And then divide, and so dx by dt would equal positive 5 when t equals 1. And you have the answer. So do you know your derivative rules? Could you do it implicitly? Could you do it as a related rate to time and be able to substitute what they're given to you? Excellent. So I'm so proud of you that you're doing your work with me and trying your best to keep your calculus skills going. Mr. G Math, over and out.